The space race between the United States and the Soviet Union was a pivotal moment in the history of space exploration, driven by political tensions and the desire for technological superiority. The origins of this competition can be traced back to the aftermath of World War II, where both nations sought to demonstrate their scientific and military prowess on a global stage. The launch of the Soviet satellite Sputnik in 1957 marked the beginning of the space race, catching the United States off guard and igniting a sense of urgency to catch up. This event spurred a flurry of activity in both countries, with significant investments in research and development of space technologies. Interesting numbers and statistics from this period include the fact that the USSR was the first to send a human, Yuri Gagarin, into space in 1961, while the United States achieved the monumental feat of landing astronauts on the Moon with the Apollo 11 mission in 1969. The space race was not just about reaching milestones in space exploration. It was also a demonstration of ideological and political power. The competition between the two superpowers fueled advancements in rocket technology, satellite communication, and human spaceflight capabilities. By the end of the space race in the 1970s, both nations had made significant strides in space exploration, laying the foundation for future missions to Mars and beyond. The origins of the space race can be traced back to the aftermath of World War II, where the United States and the Soviet Union emerged as the two superpowers vying for global dominance. The end of the war marked the beginning of the Cold War, a period of intense political and ideological rivalry between the capitalist West and the communist East. This ideological divide extended into the realm of space exploration, with both nations seeing it as a way to showcase their technological prowess and military capabilities. The launch of the Soviet satellite Sputnik on October 4, 1957, was a defining moment that set the stage for the space race. Sputnik was the world's first artificial satellite, orbiting the Earth and emitting radio signals that could be detected around the globe. This event sent shockwaves through the United States, as it demonstrated the Soviet Union's ability to launch objects into space and raised concerns about the implications for national security. The successful launch of Sputnik also marked the beginning of the space age, a new era in human history where space exploration became a reality. The United States responded to the challenge posed by Sputnik by ramping up its own space program and accelerating efforts to develop its own satellite technology. This led to the creation of NASA, the National Aeronautics and Space Administration, in 1958, with a mandate to explore space and conduct scientific research. The space race was not just about technological achievements. It was also a symbol of the broader competition between the two superpowers for global influence. The race to space was fueled by political motivations, national pride, and the desire to demonstrate superiority in science and technology. The space race was a defining chapter in the history of space exploration, shaping the future of human spaceflight and paving the way for missions to the Moon and beyond. During the space race, the United States and the Soviet Union emerged as the key players in the race to conquer space. The Soviet Union, under the leadership of Sergei Korolev, made significant strides in space exploration with the launch of the first artificial satellite, Sputnik, in 1957. Korolev, often referred to as the chief designer, was instrumental in the development of the R-7 rocket, which launched both Sputnik and the first human, Yuri Gagarin, into space. His innovative approach to rocket design and engineering paved the way for many of the Soviet Union's early space achievements. On the American side, Wernher von Braun played a crucial role in the development of the Saturn V rocket, which propelled the Apollo missions to the Moon. Von Braun, a German rocket scientist who had previously worked on the V-2 rocket program during World War II, brought his expertise to the United States and became a key figure in NASA's efforts to reach the Moon. His contributions to the Apollo program were essential in achieving President John F. Kennedy's goal of landing a man on the Moon before the end of the 1960s. Interesting numbers and statistics from this period include the fact that the Soviet Union launched the first human, Yuri Gagarin, into space on April 12, 1961, marking a significant milestone in human spaceflight. The United States, on the other hand, achieved the historic Apollo 11 mission in 1969, where astronauts Neil Armstrong and Buzz Aldrin became the first humans to set foot on the moon. These key players, Sergei Korolev and Wernher von Braun, were instrumental in shaping the course of the space race and pushing the boundaries of space exploration. During the space race, both the United States and the Soviet Union made significant technological advancements that propelled the exploration of space to new heights. One of the key technological advancements during this period was the development of powerful rocket engines that could launch spacecraft into orbit and beyond. The Soviet Union's R-7 rocket, designed by Sergei Korolev, was a groundbreaking achievement that enabled the launch of the first artificial satellite, Sputnik, in 1957. This rocket also carried the first human, Yuri Gagarin, into space in 1961, marking a major milestone in human spaceflight. On the American side, the Saturn V rocket, developed by Wernher von Braun and his team, was a marvel of engineering that propelled the Apollo missions to the moon. Standing at over 360 feet tall and weighing over 6 million pounds, the Saturn V remains one of the most powerful rockets ever built. Another technological advancement that revolutionized space exploration was the development of spacecraft capable of carrying humans into space. The Soviet Union's Vostok spacecraft, which carried Yuri Gagarin on his historic flight, was a pioneering design that paved the way for future manned missions. The United States, on the other hand, developed the Mercury and Gemini spacecraft, which were crucial in preparing astronauts for the challenges of space travel. These spacecraft were equipped with life support systems, communication equipment, and re-entry capabilities to ensure the safety of the astronauts. In addition to rockets and spacecraft, both nations made significant advancements in satellite technology during the space race. The Soviet Union launched a series of scientific satellites that provided valuable data on Earth's atmosphere, magnetic field, and cosmic radiation. The United States, meanwhile, developed the Tyros and Nimbus weather satellites, which revolutionized meteorology by providing real-time weather data from space. These satellites laid the foundation for modern weather forecasting and monitoring of Earth's climate. The space race also spurred advancements in computer technology, with both nations investing in the development of onboard computers for spacecraft guidance and control. The Apollo guidance computer, used in the Apollo missions, was one of the first digital computers to be flown in space and played a critical role in navigating the spacecraft to the moon and back. The Soviet Union's spacecraft also utilized advanced computer systems for navigation and communication, pushing the boundaries of what was possible in space technology. Overall, the technological advancements made during the space race not only enabled historic achievements in space exploration, but also laid the groundwork for future missions to Mars, asteroids, and beyond. The United States achieved numerous milestones during the space race that solidified its position as a leader in space exploration. One of the most iconic achievements was the Apollo 11 mission, where astronauts Neil Armstrong and Buzz Aldrin became the first humans to set foot on the moon on July 20, 1969. Armstrong's famous words, "That's one small step for man, one giant leap for mankind," echoed around the world, symbolizing the culmination of years of effort and dedication. The Apollo program itself was a remarkable feat of engineering, with the Saturn V rocket launching the astronauts into space and the lunar module safely landing them on the lunar surface. Another significant milestone was the launch of the Hubble Space Telescope in 1990, which has provided unprecedented views of the universe and revolutionized our understanding of space. The Hubble telescope has captured stunning images of distant galaxies, nebulae, and other celestial objects, expanding our knowledge of the cosmos. In terms of numbers and statistics, the Apollo program involved a total of 17 missions, with 12 astronauts walking on the moon's surface. The Hubble Space Telescope has made over 1.4 million observations since its launch, leading to numerous scientific discoveries and breakthroughs. These milestones not only showcase the United States' technological capabilities, but also inspired future generations to continue pushing the boundaries of space exploration. During the space race, the Soviet Union achieved several significant milestones that showcased their prowess in space exploration. One of the most notable achievements was the launch of the first artificial satellite, Sputnik, on October 4, 1957. Weighing just under 283 pounds, Sputnik orbited the Earth and emitted radio signals that could be detected worldwide, marking a historic moment in human history. Following the success of Sputnik, the Soviet Union achieved another milestone by sending the first human, Yuri Gagarin, into space on April 12, 1961. Gagarin's flight aboard the Vostok 1 spacecraft lasted just under 2 hours, during which he orbited the Earth before safely returning. This mission made Gagarin an international hero and demonstrated the Soviet Union's lead in human spaceflight. In terms of numbers and statistics, the Vostok program included a total of 6 manned missions, with Gagarin's flight being the first. Another significant milestone was the launch of the Luna 9 spacecraft in 1966, which became the first spacecraft to achieve a soft landing on the Moon's surface. Luna 9 transmitted panoramic images of the lunar landscape back to Earth, providing valuable insights into the Moon's terrain. The Soviet Union's Luna program continued to make strides in lunar exploration, with Luna 16 becoming the first spacecraft to return a sample of lunar soil to Earth in 1970. This mission marked a crucial step in understanding the composition of the Moon and paved the way for future lunar missions. These milestones underscored the Soviet Union's commitment to space exploration and its significant contributions to our understanding of the cosmos. During the space race, the competition and tensions between the United States and the Soviet Union were palpable, driving both nations to push the boundaries of space exploration. One interesting detail is the race to achieve the first spacewalk, with the Soviet Union taking the lead. On March 8, 1965, Soviet cosmonaut Alexei Leonov became the first person to conduct a spacewalk, spending 12 minutes outside his spacecraft. This milestone demonstrated the Soviet Union's early lead in human spaceflight capabilities. Interesting numbers and statistics from this period include the fact that the Soviet Union conducted a total of 5 spacewalks during the Voskhod and Soyuz missions, showcasing their expertise in extravehicular activities. The United States, on the other hand, faced setbacks in their early attempts at spacewalks, but eventually succeeded with the Gemini 4 mission on June 3, 1965, when astronaut Ed White became the first American to walk in space. This achievement marked a significant milestone for NASA and paved the way for future spacewalks during the Apollo missions. The competition between the two superpowers also led to tensions, with each side closely monitoring the other's progress in space exploration. The fear of falling behind in the space race fueled a sense of urgency and competition, driving both nations to invest heavily in their space programs. These tensions not only shaped the course of the space race, but also had lasting impacts on the geopolitical landscape of the Cold War era. The legacy of the space race is far-reaching, with lasting impacts on science, technology, and society. One interesting detail is the development of global positioning systems, GPS, as a result of satellite technology pioneered during the space race. GPS has become an integral part of modern life, used for navigation, communication, and scientific research. Interesting numbers and statistics include the fact that GPS satellites orbit the Earth at an altitude of over 12,000 miles, providing accurate positioning data to users worldwide. Another fascinating legacy of the space race is the international cooperation that emerged in space exploration. Despite the competition between the United States and the Soviet Union, the space race laid the foundation for collaboration between nations in future space missions. One notable example is the International Space Station, ISS, a joint project involving multiple countries that has been continuously inhabited since the year 2000. The ISS serves as a platform for scientific research, technology development, and international cooperation in space. Interesting numbers and statistics from the ISS include its size, which is roughly equivalent to a football field, and the fact that it travels at a speed of over 17,000 miles per hour, orbiting the Earth approximately every 90 minutes. The legacy of the space race continues to inspire future generations to explore the cosmos and push the boundaries of human knowledge and achievement. Future space exploration has been greatly influenced by the advancements and achievements of the space race. One interesting development is the rise of commercial space companies, such as SpaceX and Blue Origin, which are driving innovation and lowering the cost of access to space. SpaceX, founded by Elon Musk, has made significant strides in reusable rocket technology, with the Falcon 9 rocket being successfully landed and relaunched multiple times. Interesting numbers and statistics include the fact that SpaceX has conducted over 100 successful launches and has been contracted by NASA for crewed missions to the International Space Station. Blue Origin, founded by Jeff Bezos, is also making waves with its New Shepard suborbital rocket, paving the way for future space tourism. These commercial ventures are shaping the future of space exploration and opening up new possibilities for human spaceflight. Future space exploration holds exciting prospects, with plans for crewed missions to Mars gaining momentum. NASA's Artemis program aims to return humans to the Moon by 2024, with the first woman set to walk on the lunar surface. Interesting numbers and statistics include the fact that the Artemis program will involve the Space Launch System, the most powerful rocket ever built, capable of carrying astronauts beyond low Earth orbit. Additionally, the European Space Agency's ExoMars mission plans to search for signs of past life on the Red Planet, utilizing a rover equipped with advanced scientific instruments. These missions represent the next chapter in humanity's quest to explore the cosmos and unlock the mysteries of our universe.